Hello students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for a new session in biomolecules. Today we are going to see what are biomolecules and what are the substances coming under biomolecules. Specifically, we are going to see about the carbohydrates. Okay. So first let us see what are biomolecules. See, these biomolecules are the substances which form the basis of life. Okay. And they are closely related to various chemical reactions that are taking place in the living systems. Actually, they are responsible for growth and maintenance. Okay, the molecules of these substances are usually giant. Okay, they are giant molecules and possess high molecular masses. Since they are responsible for the existence of living systems, they are usually referred as biomolecules. Okay, so these biomolecules are the complex, lifeless organic substances that are responsible for the growth and maintenance of the living system. So what are the examples coming under this biomolecules? Carbohydrates, okay, proteins, lipids, okay, that is it's otherwise called as fat, right? And next nucleic acid. So these are the different types of substances belong to these biomolecules, okay. So under biomolecules, today we are going to see about the carbohydrates, right? So let us see what are carbohydrates. See, carbohydrates are optically active polyhydroxyaldehydes or ketones, or the compounds that produces polyhydroxyaldehydes or ketones on hydrolysis. Okay, so the carbohydrates are optically active polyhydroxyaldehydes or ketones, or these are the substances that produces polyhydroxyaldehydes and ketones on hydrolysis. Okay, actually these carbohydrates are generally composed of carbon, hydrogen and oxygen. Okay, in most of the carbohydrates, the hydrogen and oxygen are present in the ratio 2:1. Okay, these two are present in the ratio 2:1. Okay, just like that of water. Therefore, they can be represented in the general formula. So, general formula for carbohydrate is CHH2O Y times. Okay, CXH2O Y times, right? Where this X and Y are the integers and may be same or different. Okay, so this X and Y may be same or different. Okay, in fact, in carbohydrates, this oxygen is present in the form of aldehyde. Okay, what's the functional group for aldehyde? CHO. So either in the form of aldehyde or in the form of a ketone, okay, or in the form of a hydroxyl group, okay, hydroxyl OH, okay, and this H is either present as hydroxyl group. This hydrogen can either present as hydroxyl group or directly attached to the carbon atoms. Can you understand? Therefore, at present, carbohydrates are generally termed as they are the optically active polyhydroxyaldehydes or ketones, or the compounds that produces polyhydroxyaldehydes and ketones on hydrolysis. Can you understand? Now let us see the classification of carbohydrates. Okay, so these carbohydrates are classified on different bases. On the basis of hydrolysis, we can classify carbohydrates on the basis of taste and also on the basis of reducing behavior. Okay, so let us see one by one. So let us see the first type of classification of carbohydrates on the basis of hydrolysis. Okay, so it is based on the number of products formed during hydrolysis. So how it is classified on the basis of hydrolysis? While we are hydrolyzing this carbohydrate, different types of products are formed. So based on the number of the products formed, we can categorize this carbohydrate, okay, into different categories. Okay, the first type is monosaccharide. Okay, what are monosaccharides? Okay, see, the simplest carbohydrates which cannot be hydrolyzed to smaller molecules. Okay, see, these monosaccharides are those polyhydroxyaldehydes or polyhydroxyketones which cannot be decomposed further by hydrolysis to give simpler carbohydrates. Okay, so that itself will be the simplest carbohydrate. Monosaccharide cannot be further hydrolyzed to any other of the simpler molecules. Okay, so that itself is that type of carbohydrates are called as monosaccharides. Okay, example for these monosaccharides are glucose, fructose, ribose, galactose, and mannose. Okay, so the general formula for this monosaccharide is CH2 O n times. Okay, CH2O n times, where this n can go from 3 to 7. Understood? So some common examples of the monosaccharides are these: glucose, fructose, glucose, galactose, and mannose. Okay. The next category, the next type is oligosaccharide. So how the carbohydrates are classified on the basis of hydrolysis is, the first type is monosaccharide, The second type is oligosaccharide. So these are the carbohydrates which can be hydrolyzed to give 2 to 9 monosaccharides. Can you understand? This can be hydrolyzed to give 2 to 9 monosaccharides. Okay. So example, under this oligosaccharide we are having different categories. Okay. So depending upon the number of monosaccharide units furnished on hydrolysis, these oligosaccharides can be further subdivided into the following categories. The first type is disaccharide. On hydrolysis and hydrolysis of this type of carbohydrate, these carbohydrates will be giving two same or two different monosaccharides. Can you understand? So this can give either two same or two different types of monosaccharides, right? So example for this category is sucrose, maltose, lactose. Okay. See this sucrose on hydrolysis it gives glucose and fructose. These are the two different types of monosaccharides. Whereas maltose on hydrolysis gives two glucose, it's of same type. Lactose on hydrolysis gives glucose and galactose, and these are different types of monosaccharides. Can you understand? The trisaccharides on hydrolysis gives three monosaccharides. Okay, see the trisaccharides on hydrolysis gives three monosaccharides. Actually, the molecule of trisaccharide is made up of three units of same or different types of monosaccharides, which get separated when the molecule is subjected to hydrolysis. Raffinose. So the formula for raffinose is C18H32O16. Okay, C18H32O16. So it's a typical example for trisaccharide. It undergoes hydrolysis and it gives glucose. This raffinose on hydrolysis gives glucose, then fructose and galactose. Okay. So three different types of products are formed. Monosaccharides are formed from raffinose. So raffinose is an example for trisaccharide. And the next one is a tetrasaccharide. This on hydrolysis gives four monosaccharides. Okay. So the molecules of tetrasaccharide is made up of four units of the same or different monosaccharides, which get separated when the molecule is subjected to hydrolysis. Okay. The stacchyrose is an example for this tetrasaccharide, and this gives on hydrolysis glucose, the same glucose, fructose, and 2 galactose. Okay. So this stacchyrose will be giving glucose, fructose, and two molecules of galactose on hydrolysis. Can you understand? So the next one is polysaccharide. These polysaccharides on hydrolysis gives a large number of monosaccharides. Can you understand? So carbohydrates which upon hydrolysis gives large number of monosaccharides are termed as polysaccharides. So actually these polysaccharides are actually polymers and possesses high molecular masses. Okay. The molecules of polysaccharide is composed of large number of monosaccharide units as I told you earlier. The general formula for this polysaccharide is C6H10O5, okay, or N times. So this is the general formula for this polysaccharide, and this N can go from 100 to 3000. Okay. Some common example of these polysaccharides are starch, cellulose, glycogen, gums, etc. Okay. And the next category is the classification of carbohydrates on the basis of taste. So the two different categories are there: sugars and non-sugars. See, sugars, they are sweet, crystalline substances and they are soluble in water. This you all know, right? So glucose, fructose and sucrose comes under this sugars. Okay. And the next category is non-sugars. See, these are the carbohydrates which are not sweet in taste and are called non-sugars. They are usually amorphous in nature and they are insoluble in water. Okay. So the tasteless polysaccharides belongs to this category, right? That is starch, cellulose, etc. are some of the common examples of this non-sugars. Okay. Next one is classification of carbohydrates on the basis of their reducing behavior. So there are two types under this category. The first one is reducing sugars and the next one is non-reducing sugars. So reducing sugars, these are the carbohydrates that can reduce tolerance and filling solutions. And these are called as the reducing sugars. Example, glucose, fructose and maltose. Actually, this tolerance reagent, what are tolerance reagents? Actually, this tolerance reagent is a chemical reagent used to distinguish between aldehydes and ketones. Okay. See, actually, these reagents consist of a solution of silver nitrate, ammonium hydroxide and sodium hydroxide. Okay. Actually, a positive test of this tolerance reagent is indicated by the precipitation of elemental silver often producing a characteristic silver mirror on the inner surface of the reaction vessel. Okay, so these reducing sugars, that is glucose, fructose, and maltose, they reduce this tolerance reagent and produces a silver mirror. Okay, and what is this filling solution? See, this filling solution is also used to distinguish between aldehyde and these ketones. Okay, actually, what's the substance that is present here is there is bis tartrato cuprate 2. Okay, bis tartrato cuprate 2 complex. This oxidizes the aldehyde to carboxylate. Okay, this oxidizes the aldehyde to a carboxylate ion, and in the process, the copper 2 ions of the complex are reduced to copper 1 ion. The red copper 1 oxide then precipitates out of the reaction mixture, which indicates a positive result. Okay, so this positive result holds good for the reducing sugars. Whereas in the case of non-reducing sugars, the sugars that are unable to reduce the tolerance reagent and filling solutions are called as non-reducing sugars. Okay. Here the aldehydic and the ketonic groups are bonded actually. Since because the aldehydic and the ketonic groups are bonded, they won't respond to tolerance reagent or the filling solutions. Okay. So here this aldehydic group and the ketonic group are bonded and they are not free. Okay. That's why they are not responding. So sucrose, starch, cellulose comes under non-reducing sugars. Understood, students? Finally, we shall see the functions of carbohydrates. Actually, they act as a structural material for plant cell walls. Okay, example cellulose. They act as a food reserve for plants and animals. Example starch. And then they act as a major source of energy for plants and animals. So today we have seen about the carbohydrates and the different types of classifications of carbohydrates. Okay. So let us see about the glucose and its structural elucidation in my next class. Okay. Well, fine students, I hope you might have understood what I have taught today. Let me meet you with the structural elucidation of glucose in my next session. Until then, it's Dr. Anita Raj, your chemistry mentor signing off from you. Thanks for watching.